Okay, students, so today we are going to learn about fractions. Now, students, this is a very important topic. Why? Because in the exam, it has a huge weightage. Even if you do geometry, area of triangle, rectangles, they will ask you to find the fraction of the area. Even if you do problem sums, fractions is related. Not only that, fractions is related to ratio, percentage, and decimals as well. So you better get your fractions foundation strong. Okay, and then you'll be able to do well in your exams. Now, students, let's take a look at the worksheet. Okay, everyone, let's talk about the order of operations. Students, I'm sure you all heard of BODMAS, right? In school, they will teach you BODMAS. What does that mean? Essentially, if you see a multiplication sign or a division sign, they always take the priority. And later on, you will do the plus or the minus. However, there's one thing that breaks the rule: brackets. If you see brackets, they are even more important than multiplication and division. So you always have to do the brackets first. So that's the order of operations that we should follow. Okay, students? So I know there's a lot of notes here that you can read, but we'll be going through, I'll be teaching you all this along the way, okay? So let's talk about example 1. As you can see, students, there's plus, there's minus, there's multiplication as well, right? So Kate, come, help me with this. Which one are you going to do first? You're going to do plus?
3/4 times 11/5.
So you're going to do the multiplication first, right, Kate? Correct. Excellent. So students, we focus on this first, okay? And let's do it. So let's just copy down whatever we had. Okay, Abby is here. So let's just copy down whatever we have first. And now you solve the multiplication. So Kate, can you help me to do the multiplication? You take the numerator times the numerator, and then you take the...
33
Yes,
over 20.
very good. Then you take the denominator times the denominator, you get 20. Now, what are you going to do next?
Um,
Now, can we do the plus and the minus?
yes.
Let's focus on, which one do you want to focus on first, or do you think you can do all together at the same time?
Uh,
Okay, as it stands, we are unable to do anything because the denominators are all
are
different.
not the same.
Yes. Now, we
So,
can actually do all of them together, but we have to make all their denominators the same. What number are you going to choose to be the denominator? Look at all these three numbers. What do you think will be a lowest common multiple?
the lowest common multiple is 160.
Okay, I'm opening this to everyone also. Okay, Kate, you said 160, right?
No, 40, 40.
40. Yes, you're correct. So, so I don't need to open to the rest of them. You already know it's 40. So how do we get 40? We multiply this by 5, multiply this by 5, then we multiply this by how many?
2. The top is also 2.
Okay, we want to make it 40. So what should we do? Multiply by... Well, you want to make the bottom 40, right? So you multiply it by... You want to make it 40, so...
20.
Yes. 20 and 20. And the last one, you multiply it by...
2.
Okay, so we know that all the denominators are going to be the same. So let's just draw a long line and write 40 at the bottom. You only need to write it once because it's going to be the same anyway. Now, let's look at the numerator. Kate, 13 times 5, what do you get? 60. 60 what? 13 times 5.
It's 65
Yeah,
plus 140
yeah.
is 66.
Minus 33 times 2 is 66. Yes. And what do you get in the end?
You get 141.
141.
over 40.
Over 40. Okay, so 141. Are you sure it's 141 though?
Um,
So you can add 65 and 140, you get 205 minus 66. You can do your workings, don't worry. You can do it.
139.
Yes, 139. Okay, 139. Oh, sorry, 139 over 40. Now, can you help me to change this into a mixed number?
Um, it is 3
Yes, 3 wholes. Yeah.
and 19 over 40.
Well done. Good job, Kate. All right. Thank you, Kate. Students, you see, how are you going to check your answer? If you want to check your answer, you take 3 times 40, you get 120. You add the 19, you get 139, right? So you're getting back the numerator. And the denominator is still going to be the same, 40. So you know that you have converted it correctly. That's how you check your answer. So students, as you can see from here, we have to focus on the multiplication first because it takes priority over the plus and the minus. Okay? And what did we do next? We make sure that the denominators are the same before we did our plus and our minus. So let's take a look here. Students, when you see a division sign, what should you do? Anyone? Anyone knows? What should you do when you see division? Yes, Abby. What should you do?
You times it by the reciprocal.
Oh, very good. You change this into a multiplication sign, right? And this becomes the reciprocal. Now, she used a very complicated word, a very big word, reciprocal. Yeah, this is the correct word. What is the meaning of reciprocal? Reciprocal is just when you flip the fraction upside down. That's it. So for example, what is the reciprocal of 6 over 15? The reciprocal is 15 over 6. Well, students, it will be good if you know the word reciprocal. If you don't know this word, it's fine, okay? You don't need to know this word in primary school. Usually in secondary school, we use the word reciprocal a lot. But for primary school, we learn KFC. Who likes KFC? Oh, I do. I love KFC, okay? KFC means keep, flip, and change. Keep, flip, and change. When you see a division sign, you keep the fraction, you keep this fraction. What do you do to the other fraction? You flip it upside down. That means you get the reciprocal. And finally, you change. You change this into a multiply, okay? So how would it look like? So Abby, why not you continue? Okay, Abby, before we do anything, do you notice that this is a mixed number?
Yes.
What should I do?
Change it into a improper fraction.
Yes, please change it into an improper fraction. So can you do it?
12 over 5.
Okay, that means you take 2 times 5, you get 10. Then you plus 2, then you got 12. 12 over 5. Good. Now, this is a division sign. What are we going to do?
Change it into multiplication.
And what do we do to this?
Make it 15 over 6.
Yes, we flip it. Okay, now for the plus sign, we're just going to keep it there. We're not going to do anything to the plus sign. And for this division, we are going to keep, flip, and change, right? Keep, flip, and change. So we keep this, you flip this upside down, and you change this to a multiplication sign. So before you start multiplying, Abby, can we simplify? So let's look at this first. Can you simplify this before you multiply? Because if I'm going to multiply 12 times 15, it's going to be a very big number. So
15, if the 15 you change it to 3, and the 5 you change it to 1.
Good. Okay, students, we focus on these two numbers and we realize that both of them can be divided by 5. So we are going to divide them by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. And what about 12 and 6? What are you going to divide it by?
6 becomes 1 and 12 becomes 2.
6 divided by 6 is 1. 12 divided by 6 is 2. Very good. Now let's look at the other multiplication. Can we simplify it? 21.
6 becomes 1 and 12 becomes 2.
Yes. 21 becomes... What about 21 and 7? Oops, you muted. Okay, unmute.
21 becomes 3 and 7 becomes 1.
Yes, because we are dividing it by 7. So 21 divided by 7 is 3. 7 divided by 7 is 1. So now that we have done our simplification, we can write down the fraction that we have. What are you going to get over here, Abigail?
6.
6. Okay, because 2 times 3 is 6. This was much better than just now. Just now you had 12 times 15. And then you're going to spend a lot of time doing that. So we are saving time if we simplify. Students, please simplify before you multiply, okay? So 2 times 3 is 6 over, what is at the bottom?
1.
1 times 1. 1 times 1 is 1. Do I need to write the 1?
No.
No. Okay. We do not write 1. So 6 plus, okay, I'm copying down this plus. What do we get over here?
3 over 2.
3 over 2. Okay. Now, if I want to add these together, I must make sure that they have the same denominator. How am I going to write the number 6 with the denominator 2?
You write 6 over 1 and times it by 2, so it becomes 12 over 2.
Yes, you are correct. Okay. 6 is actually 12 over 2. Remember, what does this line mean? Whenever you see fractions, what is the meaning of this line here?
Divide.
Divide. Okay, students. So does it make sense? Okay, if I write 12 over 2, that means 12 divided by 2. I should be getting 6. That means 6 equals to 12 over 2. It makes sense. It makes sense. Okay. So we are going to rewrite. We are going to rewrite the number 6 as 12 over 2. So that both of them will have the same denominator. So I rewrite the number 6, 12 over 2, then you plus the 3, and your answer is?
15 over 2.
Well done. Convert it into a mixed number. What do you get?
7 and half. And a half.
You, Abby. Well done. Good job. All right, students. Anyone has any questions about this? What kind of techniques do we use here? We use KFC because when you see a division sign, you need KFC, right? And then you simplify before you multiply so that you will not be having to multiply those very big numbers. Make your life easy, yeah? Okay, let's look at parentheses. Students, parentheses is just another word for brackets. Remember just now, Abby used the word reciprocal? Reciprocal is just another word for flipping the fraction upside down. So parentheses is just another word for brackets. So when you see brackets, please make them the priority. We have to do the brackets before you do anything else. Use here. Can I ask you to volunteer for this? Okay, help me out here. Let's take a look. 109 divided by... Now we have to solve the bracket first. So we are not going to touch the divide. We are also not going to touch the multiply. So what are you going to do to this? Use here. Change it into... And what? An improper fraction. Improper fraction. Good. Do you know how to change into improper fraction? Okay, the steps for changing into improper fraction is you take this whole number, you multiply by this denominator. But don't forget to plus the numerator, okay? So can you help me? 2 times 6 plus 1, what do you get?
13 over 6.
Okay, very good. Then after that, you have this. Can we add them together? Yes or no?
No.
Not yet. So what must we do?
Change.
Change.
The denominator serves the same number.
Okay, if I want to change the denominator to the same, I can take 6 times what? Okay, usually what? Usually if you want to make the if you want to choose a number to be the denominator, it should be the lowest common multiple. Okay, you know what's lowest common multiple, right? Lowest common multiple of 6 and 7. What do you think it is? So if we want to know, we just need to write down the 6 times table. 6, 12, 18, blah, 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 blah. 36, 42, blah, blah, blah. 7, 14, 21, all the way until 35, 42. Do you notice that there's a number that's the same between them? Which number?
42.
Yes, 42. So we can say that the lowest common multiple is 42. You know why? Because these are all called multiples. I'm writing down the times table, right? So these are all called the multiples of 6. And these are the multiples of 7. So when we say common, that means the same. So which number is the same between all the multiples? We try to find the lowest one, the smallest one. And 42 happens to be the lowest common multiple. Do you notice that if I take 6 times 7, I get 42? Okay, so what should we do to this? 6 times?
7.
Yes. And then 7 times?
13.
7 times 13.
6.
7 times 6, right? Yes, 7 times 6, you get 42. Okay, let's do it. So we have 109 divided by... Okay, we already know that the denominator is going to be 42 lah. So can you tell me what number appears on top? 13 times 7. What do you get?
91.
Yes. Then 3 times 6.
18.
18. Well done. Then after that, you continue copying down the rest. So in the end, we have 109 divided by 91 plus 18. What is that? Abby, if you don't have your worksheet, just take a piece of paper first, okay, Abby? Don't worry, you can see the questions from the screen.
109 over
109 over 42. You are correct. So now you have to deal with the division. What are you going to do whenever you see a division?
flip, change,
Keep,
keep,
flip this, and then you change this. Very good. Okay, before dividing, can we simplify? Before multiplying, can we simplify first? How can I simplify? Which two numbers are you going to target? Target one numerator and one denominator. Do you know which one?
109, 109.
Very good, 109. Because you know that this is a whole number, but then there's secretly an invisible number 1 over here, right? Whole numbers is always a numerator. So this is the numerator 109 divided by the denominator 109. What do you get?
1.
1. Very good. So they both become 1 and you are just left with a 42. So now we are left with a 42 times 99 over 21. Can we simplify again? Which two numbers are you going to simplify?
42 and 21.
42, 21. Divide by 21, you get 2. Divide by 21, you get 1. So in the end, what's your final answer? You have a 2 there and you have a 99.
$198 over 1.
Yes, very good. 198 is the numerator and the denominator is 1. Do I need to write the 1?
No.
No. Well done, Yuzia. Good job. Okay, good job. So students, don't need to write the 1. Just give your answer 198 and we are done. Okay? Now, what did we learn from this? We learned that if you see a bracket, please place the importance on the bracket. Do the bracket first. It takes priority. We also use our KFC. We also make sure that we change to the same denominator. We also simplify before you multiply, right? And you also learn that when you have a whole number, it is over 1. But actually, you don't need to write the 1. We learn a lot, from one example. Anyone want to ask questions? Want to clarify anything before I move on? Zachary, turn on your cam. Okay, come, Zachary. Let's try the next example. Okay, let's try this together, Zachary, okay? Zachary, do you see any mixed numbers here?
Yeah.
Okay, let's change it.
It's 24 out of 11.
Yes, okay, 24 over 11 multiplied by the brackets. In these brackets, the denominator are not the same. What should you change it to?
7 times 3.
Yes, you make it become 21, right? So what do you get on top?
Uh,
30
39.
minus.
17.
Yes, okay. So what do you, oops. And what do you have when you have 39 minus 17?
You minus
Yeah, you minus. What is 39 minus 17?
is 22.
Got it, got it. So now before you multiply, what should you do? Same what?
Simple.
Simplify.
5.
Let's simplify these two. Okay, let's simplify these two.
It's 1 and 2.
1 and 2. Yes, because you divide them by 11. Divide by 11. These two. Can you divide by what are you
No,
what are you going to divide them? You can divide them. Divide them by which number? Both of them, 24 and 21, you can divide them. Which number are you? Abby knows already.
3.
Yes, you divide both of them by 3, correct. 24 divided by 3?
24 divided by 3 is 8.
Good. 21 divided by 3?
7.
Ah, well done, well done. Can you simplify anything anymore?
No.
Okay, you cannot divide anything anymore. So what are you left with on the top?
Um, 16.
8 times 2, 16. What about the bottom?
7.
Yes, okay, well done. Change it into a mixed number.
Um, 2 out of 2 and 2 out of 7.
Well done. If you want to check your answer, you just take 2 times 7, 14. 14 plus 2, you get 16. So you are still correct, right?
Yeah.
Good job, Zachary. Well done. So students, I'm about to ask you to complete the practice questions. I'm about to give you some time to do BCD. But before I do that, anybody want to ask me anything before you start doing this on your own? Okay, nobody asking? Then I'll give you 4 minutes to do the next 3 questions, B, C, and D. Before you start, okay, what are the, if let's say you get an answer, okay, 1 and 2/3. Okay, I would like you all to type your answer in the chat group. So how are you going to type this? If it is 1 and 2/3, then you just type 1, you leave a space, 2/3, 1 and 2/3. Okay? So everybody, when you get your answer, you can just type it into the chat group. I will tell you if you're right or wrong. 4 minutes, your time starts now. Nicholas, do you happen to have an answer for part B? Not yet, or still working? Okay, come, let's work together then. 7/2, we have to, okay, wait, hold on. When you see minus and divide, which one should you do first? Divide. So let's write down 7/2. 2 over, okay, whenever you see a division, what should you, wait, hold on. 2 over 5 divide by, we should always change the mixed number into an improper fraction first. Can you change it?
7/5.
Yes, 7 over 5. So when you see a division, what should you do? You should do KFC. What is KFC?
Keep, flip, change.
Okay, you keep this, you flip the other one, and you change this to a times. Very good. So so now do I do the minus first or the times first?
Times.
Yes, okay. Before you multiply, can you simplify?
5 and 5.
Yes, what do you get?
1, 1.
Okay, so now you end up with 7 over 2 minus what?
Minus 2 over 1.
2 over 1. What happened to this? Missing, What happened to your 7 then?
Over 7.
Yes, 1 times 7. Okay, you see 1 times 7. So you get 7. 7 over 2 minus 2 over 7. How are you going to do this? Can you minus them yet? Are you able to minus them?
No.
The denominator is not the same, right? So how are we going to change the denominators? What are you going to change it into? What is the lowest? 14. 2 times what is 14?
7.
7. 7 times what is 14?
2.
Good. So now we are going to write down the denominator is 14. So you have 7 times 7 is?
49.
Yes, this is going to be 49 minus what?
Minus 4.
And your answer is?
45 over 40.
Yes, change into a mixed number. What do you get?
Three
Yes.
and 3 over 40.
Got it. Good job, Nicholas. So do you find this easy or difficult?
Easy.
Well done. Anyone has questions? Yes, Abby, you raise your hand.
Why can't you cross out like the 2 for 7 over 2 and 2 over 5?
Because this is a negative sign, it's not a multiply.
Oh,
Yes, okay. Students, you can only cross things out when it's a multiplication sign. When you have plus and minus, what do you need to do? You must make sure that the denominator is the same. Okay. When you have times, then you make sure that you can cross things out. No problem. Okay, let's check in with Kate. Come, Kate. What are we gonna do first? Multiply first or brackets first?
Brackets.
Okay, then let's go ahead with the brackets.
It is
What should I change? The number 6 needs to be changed into number 6 needs to be changed to be the same as what?
the same as 24.
Yes, so 6 times.
6 times 4.
Yes, okay.
24 times 1.
So now we have you don't have to times 1, just leave it alone. Okay. So now you know that the denominator is 24. What is on top?
20 minus 5.
Yes. So we will end up with 3 over 5 times what?
Times 15 over 24.
Good. Should I multiply immediately? Should I just take this times this times this?
No.
What should I do first?
Cross out 5,
Simplify. Okay.
1, and 3 over 24.
So you divide this by 5, you get 3. You divide this by 5, you get 1. What about 3?
3 divided by 3 is
Yes.
1.
24.
24 divided by 3 is 8.
Good.
So it's 3 over 8.
Well done, Kate. That was good and that was fast. Well done. Okay. So, students, this is how we do it. She did it in a very smooth way. Okay, she changed the denominator first, and then she crossed things out. The numbers was very small and very easy to manage. Okay, and she got the answer very quickly. Any questions? Okay, then let's try part D. Can I get Zachary? So, Zachary,
Okay.
what should I do first?
Uh,
Times, minus, or divide?
time.
Okay, let's do the times first. Before you multiply anything, can I simplify?
No.
Look, this is 56 over what?
1.
Yeah, so you can take numerator, simplify with the denominator, right?
Yeah.
So can I take 56? Can I take 56 divided by 7?
Wait. Yeah.
Yeah, what is it?
It. It.
7 times 8 is 56, correct. So 56 divided by 7 is 8. Okay, so
1.
8. 7 divided by 7 is?
1.
And what do you get? 2 times 8.
Wait, what? 2 times. 2 times what?
You are left with these two, right?
10.
16 minus. Okay, let's do this now. Can we? So what should we do when we see a division sign?
Flip over the KFC.
AFC, all right. So we keep this, we flip this, then we change this. So before I multiply, what should I do? What should I do to the number 18 before I multiply it?
I change it to fraction.
What should I? You don't have to, you just know. So I divide this by what?
By 1, 2, and 1.
No, I'm asking you divide by what?
Divide by 6.
So
Wait,
18 divided by 6 is?
3,
6 divided by 6 is?
1.
Okay, what are you left with? You're left with these two numbers, which will give you
15 and 1.
do I need to care about the one?
No,
No. So what is my final answer?
1.
Yes, can you believe it? Such a complicated sum, and the answer is just 1. Good job, Zachary. Zachary, you have any questions about this?
No.
No? All right. Anyone else has questions? Raise your hand. Anybody? Okay, so now we are trying to learn how to learn how to spot which fraction is bigger than other fractions, right? So we are going to compare them to see who is bigger. But we have a problem, you know. They say arrange them in descending. Oh, sorry. Oh, we have an example first. We are supposed to find out which fraction has the greatest value, which is the biggest fraction, but we have a problem. You can't really compare them, right? Because the denominators are all different. How are you going to know which one is the biggest? Anybody knows? Anybody wants to try? Anyone has any ideas? No? Nobody? Now, students. Yes, Abby, you raised your hand. What idea do you have?
Change the denominator.
Good suggestion, Abby. Thank you. Students, in order to compare them, we need the denominator to be the same. So Abby said change the denominators so that all of them will become the same. Yeah, sure, no problem. Let's try, okay? Why not I change this, you know? Okay, let's change this, okay? 44 over 77. The other one becomes 6 times 7 is 42 over 77. Okay, good. So now I know that this is bigger than the other one. Yeah, sure. And what about the other two? Okay, let's just change this into 15, okay? Then I get 5 over 15 and I get 9 over 15. Yeah, I know that this is bigger than the other. Sorry. I know that the 9 over 15 is bigger than the 5 over 15. Does that help me? No, it still doesn't help me. I still need to make sure that I compare with everything else, right? So now you want me to change the denominator into, wow, what do you want? It's going to be a huge number. What is the LCM of 15 and 77? It's a really big number and I'm going to waste a lot of time. So students, sometimes trying to make the denominator the same is very time consuming. So I tell you what, why not we do this? Yes, Yuzia, you have an idea.
Change to the numerator.
Very good. Genius. Students, you see, actually we can make the numerator the same. Let's see how we do it, okay? What is the lowest common multiple of 3, 4, and 6? Is it 12? Yeah, it's 12, right? So I can make everything into 12. So I times 2 to become 12. This times 3 to become 12. Times 4 to become 12. Times 12 to become 12. So we now know that the numerator is all going to be the same, okay? So let's write down the new fraction that we have. All the numerators are going to be 12, but the denominators are different. Okay? So now that I've changed the numerator and all of them are the same, what should we do, Yuzia? Any idea? Okay, okay, let's just compare this and this. Which one do you think is bigger?
12 over 20.
Oh, very good. You're correct. How do you know that 12 over 20 is bigger than 12 over 36? How do you know? Is it a gut feeling or do you have a way? Okay, I ask you this, very simple question. When you see a fraction, what is the meaning of this line? What is this line over here? What does it mean?
Divide.
Divide. Yes. So essentially what you're doing is you're taking, this one is 12 divided by 36. And this one means 12 divided by 20. Now, user, if I take a number, okay, let's say number 100, and I divide it by 2, what am I going to get?
50.
Yeah. What about 100 divided by 4?
25.
Then what about 100 divided by 10?
20.
No lah.
10.
How about 100 divided by 100?
1.
What about 100 divided by 1000? Don't know. Okay, I tell you lah, 0.1. Haven't learned decimals yet, user. Okay, we have, do you notice something, user? Do you notice that when we take a number, we divide it by something small? You divide by something small, the answer is very big. The answer is very big. But when you divide by a big number, what happened to the answer?
Becomes smaller.
Yes, correct. So everyone, look, you divide by something small, you get a big answer. Okay? So when you take a number divided by something small, the answer is very big. But when you take the number, you divide by something big, the answer becomes very small. Okay? So user, come, help me out here. Let's solve this. The question is asking you, which of the following has the greatest value? So you look at all these, which one has the greatest value?
12 over 20.
12 over 20. So are you going to write down the answer 12 over 20? Yes or no?
No.
What should you write down?
3 over 5.
Very good. Thank you, user. You managed to solve this. Well done. So students, okay, he had a great idea. Change the numerator to the same instead of changing the denominator. And that helps us to save a lot of time. And why does he say that we need to, why did user say that we need to write the answer 3/5? Why can't we write 12/20? Because the question is asking you which one of these fractions has the greatest value. The question is not asking you about 12/20. The original question is asking you for all these fractions. So you better give your answer according to what the question gave you, which is 3/5. Okay, students? All right. Any questions? Okay, so sometimes for fractions, if you want to compare them, you don't necessarily need to have the same denominator. Even if the numerator is the same, you can still compare them. As long as you understand that when you divide a number by something big, your answer is small. But if you divide it by something small, your answer becomes big. So, students, why not I get Abby, can you volunteer for this? Abby, they want you to arrange these fractions in a descending order. What's the meaning of descending?
Your teacher call you.
Abby, what's the meaning of descending?
From biggest to smallest.
Yes, from big to small. So, Abby, when you look at these fractions, do you think it's easier for us to make the denominator the same or to make the numerator the same?
Denominator.
Denominator. And what would you like it to be?
20. You times the 10 by 2, you times the 5 by 4, and you times the 4 by 5, and you leave the 20 the same.
Yes, absolutely. So let's draw some arrows. And below those arrows, we're going to get the new fraction, okay? So let's start with the first one. What are we going to get?
12 over 20.
20 next.
6 over 20. 11 over 20, and 10 over 20.
All right. So let's rank them from smallest to biggest to smallest, because they want it in descending order. Biggest to smallest. Which one is the biggest?
12 over 20, then 11 over 20, then 10 over 20, then 6 over 20.
All right. So when I write down the answer, I'm going to write the biggest first. Should I be writing 12/20?
Yes.
No, you can't. Because the question is not asking you about 12/20. The question is asking you about all these fractions here. So we have to give our answer using those fractions. So what will you write?
3 over 5.
Next.
11 over 20.
Good.
2 over 4.
Good.
3 over 10.
Well done, Abby. Good job. Any questions?
No.
All right. Well done. Anyone else has questions? So just ask yourself, which one is easier? Should I change the numerator to the same, or should I make the denominator the same? And of course, you must know the meaning of descending. Okay, descending means going, like when you descend from a flight of stairs, that means you're walking from up to down, right? So it's from big to small, okay? Now, ascending is the opposite of descending. So when you ascend, you're going from down to up. So that means it goes from small to big. Yeah? So students, I'll tell you what. Why not? Oh yeah, so these two are ascending. They want it in ascending order. Okay, why not I do this? I'm going to let you try both of the next two questions on your own, but I'm going to label the fractions. I'm going to call this A, B, C, and D. I'm also going to call this A, B, C, D. So when you give me your answer, please give me, for example, your answer over here, you think that this is the smallest, then followed by this, followed by this, followed by this, then you can give me your answer as this. You can give this as your answer. Type in the chat group. Okay, so however you rank them, just type the corresponding alphabets and give me your answer in the chat group. I'll give you about 4 minutes to do 2 questions. 2 minutes for each question should be enough, okay? Your time starts now. Now, students, let's look at question 3, okay? Over here, we realize that it would be much easier if we were to make the numerators the same. Because can you see how big these numbers are? Can you imagine trying to make them the same? It's gonna be huge. So it's wasting time. So let's focus on the numerator, okay? We know that the lowest common multiple for 5 and 7 is 35. So let's just change everything into 35, okay? Now, what will we get? We will be getting 35 over 455, 35 over 63, 35 over 49, 35 over 90. So that's what we have. Okay. Now from here, you want to rank them in ascending order. You need to spot the smallest one first. If you divide by something very big, then your answer will be very small. So this should be the smallest one, followed by this, then this, and finally this is the biggest, that has the biggest value. So if you would like to write your answer, it should have been, you should have, in the chat group, you should have typed A, D, B, C. That would have been the correct answer for question 3. But if you're writing the answer here, you must write down the fractions themselves. This, followed by this, followed by this, followed by that. And you would have gotten it correct. That's how you do it. Yes, Kate, question.
I thought it would be 35 over 455, then 35 over 90.
The smallest answer is 35 over 455. Yeah, that's correct.
Then 90 is the second biggest number.
Which would make this the second smallest value. Let me ask you something. If I take 35 and I
It's just that I thought like the order was that way.
Oh, so you just got a little confused?
Yeah.
Okay. So let's move on to the next one. Kate, why not you just help me with the next one since you're already here? Okay, Kate, let's do the next one, okay?
Mhm.
Are you going to change the denominators or the numerators?
Mm,
Which one seems easier for us to manage?
numerators.
The numerators. Okay, good. What would be the lowest common multiple between all of these?
14. No.
Almost. Try the next multiple of 14.
28.
28. So 4 times something equals to 28.
7.
Yes. 14 times 2.
2.
7 times
4.
and finally 2 times.
14.
Yes. Okay, so now we are going to get we are going to have all the numerators 28. All the numerators are going to be 28. Oops. Okay, so 28 over
28 over 35, 28 over 30, 28 over 36, and 28 over 42.
Okay, which one? When they say ascending, what do they want?
Smallest to biggest.
Smallest to biggest.
So it is 28 over 42.
Yes, this is the smallest. Then
28 over 36,
yes,
28 over 35,
yes.
and 28 over 30.
Good.
It equals 2 over 3. 4 over 5.
Ah, follow the numbers. Follow the
No,
sequence.
no. 7 over 9.
Yes. Next.
That's 4 over 5.
And
14 over 50.
yes. Okay. Stop. You can stop looking at all. You can stop looking at all these. Okay. You just need to look at your numbers. 1, 2, 3, 4. Okay.
Okay.
Then you will not be so confused. Well done, Kate. Good job. Okay, students. Anyone has questions about this? Raise your hand. Anyone? Okay. So let's move on to problem sum, shall we? Now, students, there are two techniques that we can use to solve problem sums. We can use models or you can use branching. So let's try both. Both are important because it depends on the question. Sometimes models are easier and sometimes branching is easier. So we're going to just practice both, okay? So when we read this question, it says that Harry spent 3/5 of his allowance. So when they say 3/5 of his allowance, it means that he should have a total of 5 units. So we are going to draw 5 units first. So this represents his entire allowance, okay? So out of 5 units, he actually spent 3 units. Okay, 3 out of 5. So 3/5 on 2 soccer balls and 3 basketballs. 3/5 on 2 soccer balls and 3 basketballs, okay? So I'm just going to write down 2 soccer balls, 3 basketballs here. Then he spent half of the remainder. Okay, they said half of the remainder. We all know that this is what he has left. This is the remainder. Half of it will be 1 unit. So I'm going to label half of the remainder on more basketballs. How many more? I don't know. I don't know how many more. They didn't say, right? Okay, never mind. They don't want to say. It's fine. I put a question mark. How many basketballs? I don't know. So we put a question mark there. So next, they say that if a basketball is 1/3 the cost of a soccer ball. Okay, so how am I going to represent this in a model? Let's say this is a soccer ball. That means the basketball is 1/3, 1 out of 3, which is 1 unit. So how much does it cost? Actually, the soccer ball is more expensive, 3 times more expensive, right? What can I say about, if I want to compare the soccer ball and basketball, what can I say? I can say that 1 soccer ball is as expensive as 3 basketballs. Everyone agree? Yeah, because if I buy 1 soccer ball, I can convert it into 3 basketballs, right? So 1 soccer ball is actually equivalent to 3 basketballs. So let's just write this down. It means that 1 soccer ball equals to 3 basketballs. So now, look here. Do you notice that there's 2 soccer balls here? Why not I change them into basketballs? 1 soccer ball equals to 3 basketballs, right? So 2 soccer balls should be equal to 6 basketballs. So that means 2s plus 3b should now be, see, this is 6b, right? What is 6 basketball plus 3 basketball? That means it should be 9 basketballs. Okay, everyone agree? If you have questions, just raise your hand. I'll help you, okay? So now I know that he spent this money over here, 3 units, to buy 2 soccer ball and 3 basketball, which is actually the same as 9 basketballs, right? So we can say 3 units equal to 9 basketballs. 1 unit should be 3 basketballs. Remember this question mark? We have just figured out this question mark is 3. Because 1 unit represents 3 basketballs. Okay, the question says that he used this to buy some basketballs. And I now know that this is 3 basketballs, okay? How many basketballs did he buy altogether? Okay, students, you already know that this is 3 basketballs. So everybody, can you type your answer in the chat? How many basketballs did he buy altogether? Come type your answer in the chat. It's not 12. Students, be careful. He did not, you see, these 2 are soccer balls. I'm just temporarily changing it to 9 basketball just for the sake of finding out how many basketball is 1 unit. But in reality, when I do my working, I'm changing this to 9 basketballs. But what is the real situation? In reality, he did not buy so many basketball. He actually bought 2 soccer ball and 3 basketball. That is the reality. So, Kate, you got it, okay? Uzier, you got it. How many basketballs did they buy? He bought 3 here, correct? 3 basketballs here, and another 3 here. So altogether, how many? Total basketballs equals to 3 plus 3. 6. He bought 6 basketballs. 3 here plus 3 here. That's all. Please do not get confused by this. This is equivalent to 9 basketball. It is just equivalent. I'm just doing my workings in order to find the units. But he did not actually buy so many basketballs. In actual fact, he bought 2 soccer balls, okay? And 3 basketballs. That's the reality. Any questions, students? Raise your hand. So how are we going to do the branching method? So let's try branching now. If let's say you are not comfortable with drawing models, you can use branching. And it's really up to you. Both methods are correct, okay? So let's say the question says that he spent 3/5 of his money buying 2 soccer balls and 3 basketballs. It says that he spent half of the remainder. Can you see that the remainder is 2/5? So he spent half of the remainder. What is half of the remainder? Half of the remainder is just 1/5. And he bought some basketballs. And of course, the rest of it, he did not spend it. Okay, so he have this left. But he bought some basketballs with half of the remainder, which we do not know how many. But we already know that 1 soccer ball equals to 3 basketballs, yes or no? So if 1 soccer ball equals to 3 basketballs, okay, let's do the working over here. We know that 1 soccer ball is 3 basketballs. That means 2 soccer balls must be 6 basketballs. So if I want to convert all of this into basketballs, 2s plus 3b, if I convert everything into basketballs, that means it is equivalent to 9 basketballs. So what do we do? What do we know? This is 3/5, right? Which is equivalent to 9 basketballs. So we can just say 3/5 of the total is 9 basketballs. Now I can find what is 1/5. There, this one. I'm trying to find this question mark. So 1/5 of the total must be 3 basketballs. All you need to do is divide it by 3. You divide 3/5 divided by 3, then you get 1/5, right? So now I know that 1/5 is actually 3 basketballs. So what is the total number of basketballs? You have 3 here. You have another 3 there. Okay, this becomes 3, right? So 3 plus 3, again, is still 6. And that's how you do branching. So how many of you find that model method is easier to understand? Anyone? Ah, then how many of you, okay, put down your hand. How many of you prefer branching? Eh? Okay, so the rest of you just don't mind, is it? Both are fine, is it? Okay, okay. Any questions before I move on? Okay, the next question is very similar to this one. We can also use model method and branching method. So let's take a read. It says that he spent $24 on books and 1/5 of the remainder on a pen and a ruler. So let's say this is all his money. And let's say this $24 was spent on books. Okay, hold on. It was spent on books. And then 1/5 of the remainder. This is the remainder. So I need to divide the remainder into 5 parts so that I can know what is 1/5, right? So this is the remainder. Then he said that 1/5 of the remainder was spent on a pen and a ruler. Okay, so this is pen and a ruler. And he says, the question says that he has half of the original amount of money left. So what they're trying to tell you is, this is how much he have left. And this is actually half of the original amount of money. Right, students? So if this is half, okay, let me write this down here. Half of the total. So this is 4 units, right? So if this 4 units is half, doesn't it mean that this is also the other half, 4 units? Right, students? Okay. So if that's the case, then can I get, okay, Yuzia, can you volunteer for this? Yuzia, can I ask you, the $24 is equivalent to how many units?
3.
Yes, very good. Okay, because this is 4 units, you minus this 1 unit here, you are left with 3 units. So that means 3 units is already 24. That means 1 unit is
8.
8. Yes, $8. So that means 1 unit is $8. That means he spent $8 on a pen and a ruler, because there you go, 1 unit was being spent on a pen and a ruler. So now they said that the pen cost 3 times as much as a ruler. Yeah. So 1 unit is $8. He spent $8 on a pen and a ruler. Don't you think that this should be $8 then? So how much is the ruler? Say again.
2.
Very good. Well done, Yuzia. So Yuzia, do you find model drawing useful, or do you prefer branching?
Either one's fine.
Okay, well done. So students, you see, a pen is 3 times as much as a ruler. That means there's a total of 4 units. So how much is the ruler? $8 divided by 4. Ruler equals to $8 divided by 4, and you get $2. There you go. Okay, so this is the model method. We are also able to use the branching method for this question. Let's look at the branching method. First, we start off with the total. We always start with the total for branching, okay? So we have the total, and they say that he spent how much? $24 on books. And he spent, and then the last five units is the remainder, right? Now, the question says that he spent 1/5 of the remainder. 1/5 of the remainder is being spent on a pen and a ruler. That means the other 4 units, they said that this is actually half of the original amount. Yeah? So that's how your branching should look like. Okay. So since we know that 4 units is half, that means the total should be 4 units times 2. That means the total should be 8 units, isn't it? Now, if the total is 8 units, right? You look at this part over here. This is the total. Total should be 8 units. So this $24, right, is actually supposed to be 3 units. Don't you agree? So 3 units is $24. 1 unit is $8. And so now we know that this is $8. Okay? So how much is a ruler? $8 divided by 4. You get $2. Same answer. It's just a different method. So students, anybody want to ask questions about the model or the branching? Raise your hand. Okay. So are you ready for more complicated questions now? Now let's see here, okay? Question 6. Take 10 seconds to read it. All right. So, what does the question say? Scarlett spent 3/5 of her money. So that means if this were to represent the total amount of money, 3/5, we need to divide this into 5 units. And once we do that, then we can draw 3/5. 3 out of 5 on 12 tops and 2 dresses. And she spent the rest of her money on 4 dresses and some tops. Okay, they're not telling you how many tops. 4 dresses and I don't know how many tops. Yeah? Now, a top costs 2/3 as much as a dress. Okay, okay. We have to draw this, okay? This is a dress. And how much is a top? A top is actually 2 out of 3. 2 out of 3 of a dress. So when you compare them, it looks like this. So, do you agree, students, that if I were to buy another dress like this, but if I were to draw another 2 tops here, then they will be equal. Correct or not? What can I say? I can now say that actually 2 dresses, right? 2 dresses is equal to 3 tops. Okay? 1, 2. 2 dresses equals to 1, 2, 3. 3 tops. So that's what I can tell. 2 dresses equals to 3 tops. So let's write it down. So over here, I can tell that 2 dresses is equal to 3 tops. So how many tops did Scarlett buy? So since I already know that 2 dresses equals to 3 tops, 1, 2, 3. That means 3 units equals to 12T plus 3T, 15 tops. So 3 units is 15 tops. That means 1 unit represents 5 tops. Yeah? How many tops did Scarlett buy? So I know that 1 unit represents 5 tops. Let's find out about this 4 dresses. 4 dresses. Wait. We know that 2 dresses equals to 3 tops, right? So that means 4 dresses equals to 6 tops. Why not we find out these 2 units here? Okay, these 2 units here. How many tops does it represent? 2 units represent 10 tops. Ah, now I know 2 units represent 10 tops. And I know that these 4 dresses is 6 tops. So what is the question mark? Students, can you tell me how many tops is this question mark? How many tops is that question mark? Everybody, can you type in the chat? Okay, let me ask Abby. All right, Abby. Are you there? Okay, so
Yeah.
Abby, I managed to find out that 2 units is 10 tops, right? That means the yellow highlighted units represent 10 tops. I also
So
managed,
1 unit is 5 tops.
yes, 1 unit is 5 tops. Yes, that's true. But what's more important is the 2 units. Okay, so 2 units represent 10 tops. And I know that 4 dresses, can you see these 4 dresses over here?
Is 6 tops.
Yes.
Or
So what?
6 minus 10 is 4. So the
Yes,
question mark.
correct. Very. That means the question mark here represents 4. Okay, because 6 plus 4 is 10, right? Okay, so this represents 6 tops. That represents 4 tops. So how many shirts, how many, what is that called, tops? Question A is asking how many tops did she buy altogether? We know that there are 4 tops here. And what else did she buy? How many more tops did she buy, Abby?
12.
12. Okay, so you bought 12 tops here, and there's another 4 here. So how many tops are there in total?
16.
Well done. Okay, so she has bought 16 tops. Now the next question asks, if she spent all her money on tops, how many tops can she buy at most? Okay, that's very easy. You know why? They're asking you if she did not buy any dresses. Okay, let's imagine that she did not buy dresses and she used all the money to buy tops. 2
You
dresses,
already
yes.
you already converted the 2 dresses and 4 dresses, which is 3 tops and 6 tops, which means you can add them together and plus the number of tops that there are.
Very good. So the maximum number of tops that she can buy if she did not buy any dresses would be 12 plus what?
9.
Okay, let's do it. 12 plus 3 plus 6. And finally plus. I'm just adding everything on top. We're just adding all these, right? 12 plus, I have 12 plus 3 plus 6 plus. Abby? 12, 3, 6, and what? How many tops? The question mark is how many tops?
Right.
What?
4.
Correct. 4. 12, 3, 6, 4. So 12, 3, 6, 4. And what do I get?
25.
Well done. Abby, was this confusing?
Yes.
Yes. Do you have any questions?
No.
Okay. Thank you, Abby. Now, students, you just have to be very careful. Okay, when you do your conversion, you convert the dresses into tops. It helps to write it down because you can't be remembering everything, right? So if you have converted 2 dresses into 3 tops, I'm writing it down over here so that I can remember. Okay, I make use of the model a lot. Anyone has any questions? Raise your hand. Okay, now let's try part 7. Question 7. All right, quite a long question. Take 10 seconds to read it before we begin. Anyone have any idea how to solve this? No. User immediately shake his head. Who wants to try? Anyone has any ideas? Okay, Nicholas, come. Let me ask you something. So, Nicholas, oh, sorry. Yeah, there's a typo error here. Okay, can you just change this into cola and orange juice, okay? Now, Nicholas, can I ask you? They are telling you that, okay, let's look at the first sentence. They say that each bottle of mineral water was shared by 2 people. So if there are 2 people sharing one bottle, can you tell me what fraction of the bottle will each of them drink?
Half.
Yes, okay, each of them will be drinking half of the bottle. What about for the cola? Each of
1/3.
1/3. Yes, each of them will drink 1/3 of the bottle. What about the orange juice?
1/5.
Yes, you are correct. So can you imagine if I'm one person? Okay, let's say I'm one person. I'm drinking half of the mineral water. I'm drinking 1/3 of a cola, and I'm drinking 1/5 of an orange juice. So the total number of bottles, okay, the volume of liquid that I'm drinking, I have to add them together. So can you help me to find out the lowest common multiple?
30.
30. Yeah, 30. Good. So I'm going to convert this into 15/30. Half is 15/30. 1/3 is how many over 30?
10.
And 1/5 is how many over 30? Times what?
6.
Yes, times 6. So now I'm going to get 31/30. So what does this mean? This means that every single person drank 31/30 of one bottle. Okay? It does not matter whether it's water, cola, or orange juice. I'm just trying to calculate the entire volume, all the liquid that they drank in terms of how many bottles. Okay, so each person drank 31/30 bottles of drinks. Okay, the question is telling you that in the entire party, 124 bottles of drinks were being consumed. So do you think I can find out how many people are there at the party? What should I do to find that out?
1, 2,
1, 2, 4. Yes,
divided by
divided by
1.
correct. So if I want to find the number of people at the party, I just need to take the total number of bottles that were being consumed divided by how much does each person drink. Each person is drinking this. Yes, very good. So I see a division sign. What should I do?
Split. Change 2 times.
Very good. So can I simplify before I do anything? Divide by 31. Divide by 31 and get 1. What is 124 divided by 31? 4. Very good. So my final answer is
4 times 30.
yes, which is
120.
well done. So how many people are there at the party?
120.
Thank you, Nicholas. Good job. Do you have any questions? No?
No.
Okay. Anyone has questions? Raise your hand. All right. So let's try the last problem. Okay, students, this is a challenging problem. Hey, guess what? Actually, this problem appeared in one of the PSLE papers. Okay, so let's take a look. Take some time to read it before we start. Ah, yes, Abby.
What is a PSLE?
That's the national examination for Singapore. Yeah. Abby is from Australia, so she doesn't take the PSLE, right, Abby? Okay. So, what are they trying to tell us, students? They told us how many students are there in class A. They also told us how many students are there in class B. And now they start to compare the number of girls. Okay, so let's say they are telling us that there are 2/3 as many girls in class B as class A. So they're trying to compare the girls in class A and class B. Then after that, they're comparing the boys in class A and class B. Okay, so finally they're asking you how many girls are there in class B. So why not we do this? Okay, let's split them up. Since they want to compare the boys and they want to compare the girls, then we can split them up. So first they are telling you that there are 2/3 as many girls in class B than as in class A. Okay, so we are going to draw a model for the girls first, and we are going to compare class B and class A. 2/3 as many in class B as class A. So this, oops. So let's say we draw 2/3 as many in class B as class A. That means this is class B, this is class A. There are 2/3, 2 out of 3, as many girls in class B as compared to class A. It looks about right. So let's draw it properly. There you go. There are 2/3 as many girls in class B as compared to class A. What about the boys? There are 3/4 as many boys. There are 3/4 as many boys in class. Wait, I want to make it a little bit bigger. Okay, so yep, just gonna move this there. Okay, these are the boys. Let's draw 4 units of boys first. It's too fat. Wait. Okay, that's better. There are 3/4 as many boys in class A as in class B. So that means there are more students in class B. So if there are 4 units in class B, that means in class A, there are 3/4. There are 3/4 as many in class A as compared to class B. Okay? There you go. So now we have managed to represent the boys and the girls in class A and class B. So let's label it units and parts. Units and parts. I cannot call all of them units because you're not sure whether they're the same or they're different, right? So you have to call one of them units, the other one parts. So now what we can do is, let us combine them. I'm going to draw a model for class A, the total number of students in class A, and I'm going to draw a model for the total number of students in class B. And as you already know, students, there are 36 students in class A and 38 students in class B. That means there's a little bit more students in class B, right? So let's look at class A first. Who belongs to class A? I have 3 units of boys plus 3 units of girls in class A. So let's draw it. 3 units of boys plus 3 parts of girls, okay? 3 units of boys plus 3 parts of girls. This is a little bit too short, eh? Okay, get me a nice rectangle. There you go. 3 units of boys plus 3 parts of girls. Now, looking at class B, 4 units of boys, 2 parts of girls. Okay, let's do it. 4 units of boys, 2 parts of girls. There will be, class B has more students, so it's going to be a little bit longer. 1 unit, we are supposed to have 4 units, right? 1, 2, 3, 1, 2, 3. Okay, and plus 2 parts, right? 4 units and 2 parts. Let me just draw the 2 parts first. And then the remaining must be 1 unit. So students, look here. I have 1, 2, 3, 4. 4 units plus 2 parts. That is correct. For class A, I have 3 units and 3 parts. That is also correct. But why am I purposely splitting up the units and the parts? Everybody focus your attention here. What do you notice? You notice that there's a 1 unit is a little bit bigger than 1 part. Everybody, can you tell me what is the value here? What is the difference between 1 unit and 1 part? Type it in the chat group. What is the difference in the unit and the part? Yes, Zachary, correct. Who else? Who else knows? Correct, Uzia. Well done. Who else? Let me give you a hint. The question already told you class A has 36, class B has 38 students. So students, what is the difference here? Can you all tell me? So far, only Zachary and Uzia has told me. What about Kate, Nicholas, Abby? What is the difference there? Do you know? There are 36 students here and there are 38 students here. What is the difference here? Huh? Kate, Nicholas, Abby, do you know? Okay, Abby, let me ask you. Abby, do you know what's the difference here? Huh? Yes, it's 2. Very good. Okay, because 36 minus 38 is 2. So now we are able to compare 1 part and 1 unit. You realize that 1 unit is actually equal to 1 part plus 2 because the difference is 2, yes or no? So let's convert all the units into 1 part plus 2. Yes, and you already know that class B has 38 people. So what are we going to do? Let's count how many parts there are. 1, 2, 3, 4, 5, 6. 6 parts plus 2, 2, 2, 2. That means 8. Equals to 38 students. Therefore, 6 parts must be 30 students and 1 part is 30 divided by 6, which will give us 5. The question is asking you how many girls are there in class B. Look for the girls. Look for class B. How many girls are there in class B? Students, please type your answer in the chat now. How many girls are there in class B? No, Yuzia. Actually, there's only two parts of girls. There's only two parts of girls. Yes. Okay, Yuzia got it. Zachary, no, that's not. Zachary, there's two parts of girls, right? In class B. Look here. These are the girls. This is class B. There's only two parts of girls here, right? Two parts of girls, right? Yes, Zachary, you got it. How about Nicholas, Abby, and Kate? Do you know how many girls are there in class B? Okay, Kate, let me ask you. Kate, we know that one part equals to 5, right?
Mm-hmm.
Can you tell me how many parts of girls are there in class B?
Mm,
It's being drawn over here, isn't it?
There are 10
10 what?
girls in
Yeah,
class B.
very good. So if I want to find the girls in class B, then I must find the two parts. And that will be 10. Well done. Why didn't you type your answer if you already know it? Or you're still thinking, is it? Or you're not sure?
I just got a little bit confused because I did not know why you drew the model on the bottom.
Oh, you don't know why I'm drawing this model?
No, because like if you already know that the top is 10, then they answered the question. You don't need to like draw the model on the bottom.
The top is 10. Where? Oh, okay, Kate.
Like do you need to find the part where like like the
The difference
two
is
at
what?
the end?
Oh, do I need to? Well, Kate, if you already drew the model here on top,
Mm-hmm.
will you be able to tell from here what is the value of one part?
No.
No, and that is the reason why I purposely drew this model at the bottom where I'm combining everything, 3 units and 3 parts. Okay, this is the
Okay.
the boys and the girls from class A, right?
Mm-hmm.
And then for class B, I'm combining 4 units and 2 parts for class B, right?
Okay.
That actually helped me to align them. I align them like this, and I very clearly compare the difference between 1 unit and 1 part. Okay?
Okay.
All right. Well done. So students, we managed to solve this question. Does anyone want to ask question about the model drawing or anything else? Raise your hand. How many of you felt that this question here is challenging? Oh, yes, it is. Yeah. Actually, a lot of students could not solve this when it came out in the exam. Okay. So this is just some of the challenging questions. Of course, we'll have to be doing much more challenging questions in order to do well, so that you'll be exposed and you'll get used to all these questions. Okay. So everyone, well done today. We've managed to complete the worksheet. Now, what did we learn? We learn about the order of operations. We learn about KFC. We learn how to compare which fraction is bigger. That means you can change the numerator to be the same, or you can change the denominator to be the same. We also did a lot of problem sums, model drawing, and also branching, right? So I tell you what, especially for the problem sums, which are more difficult, please, after 2 or 3 days, try to do it again. If not, you'll forget how to do it, right? So revision is very important so that you'll improve yourself. Okay, students, if any of you have any questions, you can stay back and ask me. If not, I'll see you next week. Bye, everybody. Bye, Yuzia, Kate, Nicholas, Zachary, Abby. Bye.